Guys, can you hear me now?
Yeah.
Okay,
Yeah,
sorry.
now we can hear you.
There is some
Yes.
network issue. There is some network issue on my side. All right. So we talked about data warehousing, and we talked about the concept of designing a data warehouse, like the following the process of ETL, extract, transform, and load. Every one of you now understand what is a database, what is a data warehouse, a placeholder where information is kept in tables and columns, and everyone have their information stored in these tables: client information, account information, transaction information, anything like that, inventory, human resource. Now, testing, when I was talking about testing lecture, I was giving you an example of different environments. So this is the actual environment. That data warehouse is your actual environment. That is where eventually your application is going to get launched. Once your application is implemented, the last day you will start getting real data from a data warehouse or a database. Before that, they will have copies of this data warehouse, mirrored image copies, mimic data, past data. That data will be used just for the development and coding purposes and testing purposes. And eventually, once everything is done, application is secure, that every single bug have been fixed, every single defect have been fixed, then it is going to be launched on a data warehouse. There are a couple of concepts which I would like to talk about when it comes to a database. Mostly a question is asked like, what are different types of keys in a database table? So keys are nothing but the columns, and there are certain columns which are unique. For example, when you join a school or a college or a university, and when you enroll in one specific class, they give you student IDs. Why? Because there could be two Emilys in class or three Emilys in class. So when teacher is calling them, they can call them with their roll number or with their student ID. Same way their data is stored. When the information of student goes in the table, it goes with the student ID numbers, and that column where everyone's student ID is mentioned, that column is called primary key column. So a primary key is a unique key column which distinguish every single record in the table. Every single record will have a different key. Every single student will have a different student ID, so it is easier to recognize them. So the most important key in any database is going to be called primary key. Now there's another key within your table, and that is called alternate key. So alternate keys are not primary key, but they can become a primary key. Okay. For example, you have a student ID and you have a roll number. So, or you have an email ID. In same table, when student information is being kept, you have a column called student ID, roll number. Let's suppose roll number is also student ID. So let's not even consider this. There's a column called first name, last name, and then there's a column called email ID. So every student is going to be unique student, and they're going to have their unique numbers, student IDs. Their name can be same: first name Emily, last name Huang. Let's suppose, just giving example, cow. So here, when it comes to email ID, it is again going to be unique because your email records are unique. So that email ID can also become a primary key if required. But because we already have assigned a primary key, we don't need that. And because email IDs are lengthy, they are complicated, so calling every single record by their email ID is not going to be physically possible when it comes to huge sets of data. So that is why an alternate key can become a primary key. Okay. As same way, candidate key is a key which can become, which is a candidate to become a primary key. Basically, it have the values, the properties of primary key as well as unique key. There's a key called foreign key. This is nothing like something which you should know always, but because these are basics of a database, and sometime if they ask you during an interview, you should be able to tell them within a table what kind of keys exist or what kind of column exist. um, Foreign key basically, if you have to connect two tables, I have a student table and I have a course table, and I want to see within my database which student have enrolled in chemistry. So if I want to connect, want to join these two tables, I will pick one from here and I'll pick one column from here on which I can connect them, and that is called the foreign key, because this key will go and sit in the student table, or student table will sit in the course table once you're trying to find out which student have enrolled specifically in which subject. So these are different types of basic keys which you need to know. Another concept of database, this is just for the definition purposes. Okay, I've sent you some notes. You can read the chapter 1 where all these basic concepts are explained properly with the examples. So please read these keys. This is important. The second thing which is important to know is schema or a design. How your database is designed, what are different types of schemas in your database. Okay, so there are two different types of schemas, generally star schema and Snowflake schema. Most databases, most simple databases are going to have star schema, and star schema will have a fact table in the center and dimension table connected by this fact table. What does that mean? The fact table is going to calculate or capture your numeric information, numeric record within your database. If your database
Imran,
is designed,
Imran, you keep breaking.
I'm sorry.
Yeah, I mean your voice keeps breaking.
Okay,
It's
I'm
not really
having
clear.
some issues. Let me switch to another network. So it's gonna be couple 1 minute pause. So hold on 1 second. Let me connect with the other internet. I think. Is it better now or is it still same?
Mm, it's better. So let's continue. If it happens, I'll let you know.
Okay, please do let me know whenever I'm breaking up. There's some issues in my area today. Uh, so schema or design, this is basically structure of your database, how databases tables are going to be designed. Every database will have multiple tables. For example, in Bank of America, you have a database of investment banking department or commercial banking department. And when they're going to design this database, they're going to have multiple tables in it. They will have customer table, they will have transaction table, they will have account table, they will have KYC table. Different other tables are going to be part of this database. And if it is a simple database design, they don't have too much of information overload, they will always go for a star schema. And star schema basically will have one central fact table and connected dimension tables. What is a fact table and what are dimension table? So fact table basically is your table where all your changing data will be kept. Every day changing data is basically your account balance, type of transaction amounts, and all those things. Same way, if you talk about a department, their sales is changing, their revenue is changing, their expenses are changing. Any information which is numeric and which is changing, it is going to be part of a central fact table. And every other information will be part of your dimension table. Like for example, first name. Your first name never changes. Customer first name will always be first name, last name mostly will stay last name. Your date of birth never changes. Okay, few information are also there which are, so the information which is static is going to be part of your dynamic table, and information which is changing or dynamic, it is going to be part of fact table. So this is confusion. Sometimes people think dynamic table is going to change and fact table is not going to change, but it's other way around. Your fact table will have numeric and changing values, revenue, sales information, account balances, all those things. And your dynamic tables, your dimension tables, D basically is dimension, not dynamic, sorry. So your dimension tables are going to have your information which is never changing. Most information will never change, date of birth, social security, all those things. Few things still can change. That's a tricky question. Sometimes they will ask you, does any information change in your dimension table? Because customers are coming, they're leaving, they're coming back, and all those things. Does this information change? So you will say no, mostly it doesn't change. But customer address, which is also part of your dimension table, that information sometimes changes. Customers change their address. So this is a simple design. Star schema will have one central fact table and multiple dimension tables connecting to it, and it is centered. There's no other connectivity. Now there's another schema or a design called Snowflake schema. What is a Snowflake schema? Snowflake schema basically is used when you have large sets of database, large sets of information. And when you don't want to put your information in few tables. I gave you one example last time that there are different types of table, like centralized and decentralized information. Centralized information basically mean that you are going to keep information in multiple table. One customer information can be kept in multiple table: customer table, customer address table, customer KYC table. And if you're talking about denormalized data, which is basically a data warehouse design, usually you will have within your data warehouse, you'll have a denormalized data. Denormalized data mean that most of the information will be pumped into single table. All the customer information, address information, KYC information, basic information, every single thing will be kept in one single customer table, which might have 70, 80, 90 columns. So when you're looking for information and you're looking for a decentralized information, you will always go for a star schema. But when you want to centralize information and when you want to break down your information into multiple tables, then you will go for a Snowflake schema. And Snowflake schema will have multiple fact table and dimensions connected to these tables, and they are connected to each other, and it is going to be a complex design. It's like a snowflake. Okay. Now, so snowflake schema mean centralized data, and star schema mean decentralized data or decentralized information. Why I want to know this as a business analyst? Because when I am doing my analysis and I'm building an application where I'm going to bring information from multiple tables, I want customer information in this application, their transaction, their account information, their KYC information, anything like that. I want to bring all this information in the application. So I need to know which database design I'm going to use. If I am going to work in an application, mostly I am going to use a decentralized data. Why is that? Because most of your application will be created from a decentralized database, from a star schema database. The reason is I want to connect multiple tables to do my analysis. I want to see which customer have done what transaction, how many accounts they hold, what is their KYC information, all together in one line. On my application, there's only single search. I can only search for a client in every single thing I can see on the front end of my application. So that is why less the tables, easy for us, for the IT team, to bring that information together and process that information faster. More table, you need to connect more tables through multiple joins. You're joining multiple tables at one time and your SQL query speed will go slow. Same way your application, when application is developed, when application is built, when customer are searching for some result, your application will be slow because application is trying to pull data from multiple tables. That is why you're not going to design, most of the time you're not going to design or work in a Snowflake schema or a centralized schema database. You're most probably going to work in a decentralized database where you have less table and most of the information is pumped into these tables, and that is why your query speed will be faster and your application which you're eventually going to deliver to business user is going to perform better. Does this make sense?
Yes. I just have one question, Imran. You said in Snowflake schema, there are multiple fact tables as well, because I read somewhere there is only one fact table and there are multiple dimension table which are being extended.
Okay.
Like in dimensions, if your data is stored year-wise or month-wise or daily basis, you can extend it on for one dimension. You can store your data as daily basis, or another table for monthly basis, and another table for yearly basis.
100% right. Okay, that is why I'm only putting two fact table. Okay, reason is
Okay.
when you
So
talk about
there can be multiple fact
there
tables.
can be multiple fact table. Usually they could be two or three, most they could be three. When you're talking
Okay.
about huge data sets, Microsoft
Hmm.
or IBM or certain companies which have so many clients and so many customers and so many products, Amazon. When you're having Amazon as your company and you want to design a data warehouse for Amazon, then you cannot go with one fact table. There could be certain records, I don't know the actual number, how many millions of record can be stored in one fact table. Snowflake schema is not going to have multiple fact table. It is going to have one or more than one fact table, but your dimensions are further connected. See, these dimensions are further being broken down. But it's a good question. So you cannot just say there could be 10 fact table in Snowflake schema. Still, there could be maximum 2 to 3 fact table in a Snowflake schema when records are huge. But if it's the changing records, the values, the sales and revenues are not that huge, then you can still go with one fact table in Snowflake as well. But again, your dimensions are broken down. One of your dimension table is customer table. And if you are working in Snowflake star schema, which is a basic schema, all your customer information, whether they are 70 information or 80 information about one particular customer, all these information will be stored in this one dimension table. But when you talk about Snowflake schema, this customer dimension table will be further broken down into customer address table, that is one dimension, and then customer KYC table, that is another dimension. So you're further breaking them down. But a good question. Okay, anyone else?
Imran, so if I'll say like in star schema there is one fact table and there is multiple dimensions, but in Snowflake schema I can say there is a one fact table and multiple dimensions,
But these dimensions are
but the
further
dimension
connected to
tables
each
are
other.
further breaking down. Yeah.
Exactly.
So even one fact table, if I say so, it's not wrong, right?
No, it's not wrong. It's not wrong. I just gave you example of one case scenario where you have huge sets of data. Talking about big
Right.
corporations. Okay, guys.
Yes,
So,
right.
so
Yeah.
this is basically, so these are few things you need to know in terms of your general understanding when you're working on databases. Again, you're not going to see this design. You're only going to feel it. When you open a database, once you see so many tables underneath one database, you would know, seems like this is a Snowflake schema. But when you see there are few tables, or just open one customer table and see how many informations are filled in, popped in. If most of the information of customer table is in that table, that means you're working in a decentralized database, which is going to be the case most of the time. This is one reason. Second reason I was talking about these things is because sometime when you're working as a BA and you have multiple interviews going on, sometimes you will see people who are interested to know your data skill, because they are looking at you as somebody who can work with the ETL team or data mapping team, and they need somebody who understands this. So they might ask you questions, and what are those questions they will ask you? They will still not go in details because you are not a data analyst or technical analyst, but still they will ask you certain questions like what are different types of keys and database. So this is that you need to read. They can ask you what are different types of schemas in your database, which is star schema and Snowflake schema. They will ask you type of data. Is it decentralized data versus what is centralized data? So centralized data and decentralized data. They will ask you what is an OLAP system, what is an OLTP system. What is OLAP system? Online Analytical Processing System. Basically, this is nothing but your data warehouse, where all the information is stored for the reporting purpose, decision making purpose, and application development purpose, while your OLTPs are all those applications and all those system in one company which are running to capture day-to-day information. For example, or for instance, within a bank, ATM machine, mobile application, bank teller system, trading system, different system application which are being used by a customer, they're capturing information, and that is why we call them online transaction processing system. These systems do not store data for longer time period. You cannot use this data for the analysis purpose or decision making purpose. So that is why you bring all the data and connect that data to the OLAP system, which is your data warehouse, through a process called ETL, and they can ask you what is ETL. So extraction, transformation, and loading of data. So these are mostly all the concept, and the most important thing they can ask you how much of SQL you know, and within SQL what kind of queries you know. Select query, group by, order by, Hamming, count, and join function. These 6 to 7 queries. There are different websites where you can read it. You can use I think onekeydata.com. That is one you're going to read. All the definitions are on one page, onekeydata.com. The second you're going to use for, so this is for all the data definitions. And number 2, you're going to go on w3school.com, and that is for your SQL practice, where you can practice SQL. They have their own database. They have few tables in that database. They will first teach you what is his select query, and then they will ask you to yourself execute that query, write that query, and then you'll be able to pull result from their database. Okay, so please use this time w3schools.com, one key data. And if you want to just listen to the SQL concepts, then go on YouTube, and there's a guy, his name is Kud Venkat. Just write down Kud Venkat SQL. On whole SQL, he have around 45 to 50 videos. Each video is 2 to 3 minutes long. I want you to watch first 10 to 15 videos and learn all those queries which I talked about, and then you can use that to practice on w3schools.com. Okay, so everyone note it down.
Yes.
Sir,
Yes.
I have a question.
Yes.
Because I don't have a Windows computer, so when I go to the w3schools.com, will that affect me like practicing?
No, nothing. Just Google. When you go on Google, you're going to write down w3schools.com. It's just a website, simply like a website. You're going to open it. It's not a software. It's just a website. So you can open any website on Apple as well and start using it. It is not. Is it a case with anyone else, guys? I think it should be okay.
No, it's okay. It's an internet browser, so you can do
just
everything.
use your internet browser. Just use your internet browser. This is the application within the page on the website. It
Okay.
have nothing to do with downloading any application. Already it's part of the website. They will show you database. They will give you a page within the data within that application, and you can execute all your queries. You can write your queries.
Imran, can I add one thing?
Yes, please.
For instance, you guys can install SQL Microsoft database 2014 or 16. I guess I have the 2014. And you're going to work with the real database, which is Northwind. And also eventually you can install EPUB, the database on SQL Microsoft. And there you can practice everything.
Guys,
so it's Northwind, EPUB.
Guys, do that.
And that's fine.
Is it free? Is it free? Is it free trial version? What is it?
No, it's free. You just install SQL Microsoft, and it's free. It's but you can install that just on Windows. So if you have, for instance, Linux, you should the simplest.
My question is, do they have to have a CD, or they can have a burn version or copy of SQL? Can you email us, anyone, or is it available easily on Google?
On Google.
Okay.
Just go on Google, and I believe W3 Schools, he mentioned that too, and maybe they have a link. I don't remember if they have a link or not. Yeah, but W3 School is based on Northwind database, which is free.
Thank you. Guys, got it?
Sure.
Install SQL Microsoft Database 2014 or SQL Server. First download it and then install the database 2014. Database name is Northwind within SQL. Once you click on Northwind, you can see all the tables in Northwind database, and then you can execute your queries which you've learned from w3schools.com or YouTube, or simply they can also show you. Okay, I'm taking this out. Now, the last part of your business analysis, the last topic of your business analysis is called data modeling. What is data modeling? So modeling the data, changing the data. Remember the concept of T, transformation. Extraction is basically when you're extracting data from any system, you as a BA are only doing one thing, that you're providing a mapping document. You've done your analysis, you've given a mapping document. Now they are going to follow your mapping document and extract the data. Once they extract the data, they're going to bring that data into the transformation area, which is called staging area. And within staging area, they're going to do data scrubbing, data mining, which I don't do. Data scrubbing I don't do. And last thing to do is data modeling. They're going to model data. Model mean they're going to design how this information is going to become part of the target source or the final source, which is your data warehouse. How many tables are going to be part of the new data warehouse? Within each table, what information we are going to input? So that is called modeling, and they have data modelers for that. Mostly you will have a team member whose title is data modeler, and the tool they use is called Arvind Data Modeler. That is also available. You can also download it and practice if you want. I won't force you to do that or focus on, because you might not have a chance. But again, we have to prepare for anything in interview, or even if you need real life, if you find some kind of scenario where they ask you to create a data model, then you need to know how to design a data model. So what is data model? Data model basically is a workflow or a process flow diagram which shows how your data is going to get stored and what are going to be the tables in which your information is going to get stored. So this is what you do, and you design it through Arvind Data Modeler, and the diagram through which you design it is called ER diagram. What is E and what is R? So E is entity and R is relationship. What is an entity? Entity is anything for which you can save information, for which you can store information. A car is an entity. You can have a car table, vehicle table. Vehicle ID are the information within it, attributes basically. Vehicle name, vehicle model year, vehicle color, vehicle price, vehicle engine capacity, vehicle transmission. all those information regarding that entity can be stored in your columns, which is your attributes. So entities are generally your tables in the database. So first of all, you need to identify how many entities are going to be part of the data warehouse. As I said, when you're extracting the information from multiple OLTP system, multiple sources, information is coming from so many tables. And usually your OLTP systems are centralized. They have multiple tables. They want to store data specifically to each table, so it is easy for them to understand where the information is. Because when you talk about data warehouse, most of the information is dumped into one single table, and sometimes it duplicates, which can only be used for reporting purposes, but not for the other things where you capture the data of your revenues and sales and all those things. So entities basically are your table, and you need to identify how many tables are going to be part of the final source now. Whatever tables you had earlier in OLTP system, whatever information was coming from there, that is a history. Now you need to think that all this information which we captured, how we are going to give it to each table specifically. And again, that requirement is given to you by your database design team. Now your database design team will sit with you, and they will identify how many tables are going to be part of this final source system, and within each table how many columns we are going to have, and how these tables are relating to each other. Why a relationship is needed between each table. For example, there's a three table in a database: customer table, account table, and transaction table. Why we need to relate, why we need to have a relationship between these tables? Because if I want to check which customer have done a wire transaction in last month, I can simply not go to just customer table and find this information. I have to go in all these three tables. So if one by one, if I'm going in this table information and finding out, it is going to be very difficult, because we have millions of record. And if I want to do analysis of all these customer, then am I going to go in each table individually? So no, you have to have a relationship between these table where you relate these table through primary key and foreign keys. The same example I gave you, why keys are there. So you relate these tables using SQL Server queries or Oracle Server queries. You write down a query where you connect these tables, and the query you write is called join query. So when you connect these tables, you can simply get the information about that client from all these three tables. So that is the reason the relationship is going to be existing in every single table. All these tables are going to relate with each other, but what are those relationship types? How many types of relationship exist between tables? That is the question. So that is I'm going to explain you now. If you want to draw an ER diagram, given that you don't have a data modeler, you will be using Irwin data modeler, or you can also use a Microsoft Visio, which you've used. If you have used for creating your use cases, please try to find out Microsoft Visio, download it, use it, draw different workflows, draw different use case diagram, activity diagram, get practice on it. Okay, more you do practice on Microsoft Visio. And the most important tool, which is not related to this topic, but the most important tool you are going to use in your project as a business analyst is going to be called Excel. So learn those small formulas, the basic formulas of Excel: average function, sum function, you're doing analysis on it, how to differentiate columns and all those, how to do pivot table, how to do VLOOKUP function. So these two, three things are very important to know. They will also ask you, do you know what is a pivot table? Or do you also, can you do a VLOOKUP? What is VLOOKUP? What is HLOOKUP? So these kind of small things, small formulas in Excel, please use that. And then the second most important tool is going to be Microsoft Visio. If you are going to design any workflows, your companies will have Microsoft Visio. You will get access to Microsoft Visio. So now coming back to the topic, what is ER diagram? How do we design it? I'm going to give you an example of one database and then we'll start from there. So in ER diagram, have 4 steps to draw it. Number 1 is identify all the entities. That means find out from the database team or the business team, get the requirement, identify how many tables they want within one specific database. So for example, let's design a database or a ER diagram of a department of one university. There's a university and they have a department, chemistry department or physics department, and they want to design their database, and they have given you this task and you are going to design a model for them. So first of all, your question would be how many tables are going to be part of it. Generally you would know. So first of all, you will have a table called department table where your department information is mentioned. So this is your first entity. Second entity is going to be courses which this department is offering. Within physics, is it offering applied physics or whatever physics? There are different types of, I always hated physics. Okay. The third thing could be your instructors or teachers. And this is the notation. This rectangle sign is the notation for an entity or table. And then the fourth thing could be your what, students. And fifth thing could be your, if you want to keep that data, you can have your HR table where your HR information is there, who clerical level staff and all those things. So we identified that there are going to be 5 tables which we need to have to fill in all the information which is part of our department. So that is your first step, identify entities, and these are the entities. Number 2, you are going to identify relationship between these entities. And there are 3 different types of relationship which can exist in a database. One-to-one, one-to-many, and that is a rare relationship which will usually not exist most of the time, but sometime if it does, then many-to-many relationship. So these are 3 different types of relationship. What does that mean? So think of each table and compare each table with each table. Let's take first instructor table. So what kind of relationship exists between, and other way around, you have to see both situations. What does this have to this and this have to this? So department and instructor, what kind of relationship can exist between department and instructor? One department can have many instructors. This is the sign for many, crowbar. Is there any other relationship between these two tables? Either many-to-many relationship or one-to-one relationship or something like that? Anyone can think of any relationship between these two tables? So this is one department, many instructor. Now at the same time, a department, one department will be headed by one of the instructors. If you want to find out information who is the dean of the department or who's the director of the department, then of course you have to find information within the instructor tables because he's one of the instructor. So that department with instructor, there are 2 different types of relationship. One department can have many instructor, and same time one department can have one instructor who is heading him, and you can write down headed in this. So this is a notation for the relationship type. Now let's take department and courses. Now anyone can tell me what kind of relationship is there between department and courses?
One department can have many courses.
One department can have many courses. Let's save the space. One department offers many courses. You can write down M here. If you don't want to put that crowbar, they would know one to many. Is there any other relationship between these two tables? I don't see any other relationship between department and course. There's no many to many. There's not many departments, and there are not many courses. If there are many departments, that's a different story. You're talking about one department right now. So there's one too many. Can one department offer one course? Yes, but in ideal scenario, it won't. One department will offer multiple courses. Now, what is the relationship between department and students? One department will enroll many students. And what is the relationship between course to student? One student can enroll in one course. At the same time, one student can enroll in multiple courses. What is the relationship between instructors and courses? So because space is not enough, so I'm going to do this. So one instructor can teach many courses, and one instructor can also teach one course. So whatever way possible. So you're defining relationship between all these tables. Same way instructor and students. One instructor can teach many students. One instructor cannot teach one student, because if instructor is there, he's teaching a class, then there should be many students to be taught. So you need to think logically as well. So these are, let's suppose these are different types of relationship which we think are part of our database. The third thing I'm going to identify primary key of each table. Primary key mean any column which you are thinking is going to be called a unique key, which is going to identify every table, every column uniquely, within table, every column uniquely. So for course, you're going to have a primary key called course ID, and this oval shape is your key. And then if you put an underline underneath that, then it is called your primary key. A student's primary key is going to be student ID or roll number, and underneath there's a line which will identify that this is a primary key of this table. Instructor ID is a primary key in this situation. Department, there's no department, there's only one department. You don't have to have ID, so we can use department name as well, because one university will not have multiple department with same name. So department name can be used here as a primary key. The last part is identify rest of the data attributes. Now you're not going to only store one information in these table, which is IDs. You're going to store multiple information. So whatever we've gathered, we've talked to the business team, and they said for course we want to store course name as well. Now there's no underline. These are rest of the key. What else? Course duration. What else? Course fee. What else? Anything you think of. For a student first name, student last name, student date of birth, student address, all this information. For instructor IDs, instructor name, instructor pay scale. For department name and department location or address. This is called your complete ER diagram. 4 steps, and then final step is draw ER, which we already drawn. Do you guys understand this? This all information is being given to you. You're just using your Urban Data Modeler to drag and drop these notations, these arrows, one-to-many signs, crowbars, making sure you're fulfilling their requirement. Anyone have any question on this?
So just double check. Is this done by using Visio, like
Both
the
Visio
software?
and Arvind data model. If you go in Visio, they will ask you, they will tell you different types of diagrams, use case, activity. Underneath that, you can simply go in business process flow diagram, or they will have data modeling diagram. Once you click on data modeling diagram, they will give you ER diagram, and underneath ER diagram, within one page, they will have all these notations.
Okay, good to know. Thank you.
Okay, and you just drag and
Hello,
drop
Imran.
in the main page and connect these arrows. So this is your,
Imran.
yes.
So what would you recommend? Would you recommend I start
This,
learning how to use Visio, or I should continue with using Lucid charts, and
use
then
Lucid chart.
once I,
If you have a ER modeling diagram in Lucid chart, please use that. Again, guys, it have nothing to do with the tool. Only thing you need is these notations, these oval signs, these rectangle signs, these crowbar, these many, these decision box. This is what you need. Even if you have it in word shapes, you can still connect these. But that is why they say,
okay,
because they use professionally Visio, go with Visio if you have. If you don't have Visio, use Lucid Chart, use Balsamic, use Arvind Data Modeler, any tool which have all these notations. That is the only
okay,
question. Okay.
okay.
Now, one thing which I didn't tell you is a data model have three models within it, three phases you can call: conceptual model, logical model, and physical model. So what is the conceptual model? So when you did first step, when you identified your entities, only understanding what are going to be the tables within this database, when you capture this information from business users or database team, you have already designed a conceptual model. When you talk about defining relationship, finding primary key and finding rest of the keys, you found your logical model. You can draw it and you can pass it on to the development team or ETL team. And when they follow your model, take this data from the staging area and store this data into the final source, final target system, which is a data warehouse. And now eventually you can see actual table in your database and actual information in your database. That is called your physical model, which you can actually see. So if a question comes in your interview, what are different types of data models? Then answer is conceptual, logical, and physical model. Conceptual model is basically at the initial stages where you have a rough idea about the tables which are going to be part, or the entities which are going to be part of your database design. And when you have the information regarding the relationship between these tables, and within each table what are going to be different types of attributes and primary key, all the data, their information, that is called your logical model. And when actually the data warehouse has been designed, and you can see your table and column with the information, that is your final physical model. Any question, guys?
So I just wanted to confirm, like, given an example for data modeling types. So conceptual model will be like a blueprint of a house model.
Yeah.
And logical will be what are the materials required to build that model.
Plan of action, everything you have in your hand now.
Okay, and physical will be the implementation,
The
basically.
implementation model when it is being implemented. Very good. Who's there? Sorry,
Okay.
who's
Vasundhara.
Vasanta? Good. All right.
Okay. Okay.
This is
Thank you.
your complete BA, guys. Things which you have learned, or at least I've taught within this time period, and I hope you learned. Because if you haven't, any topic is there you want me to repeat, I'm always there. We can do it. The things you have learned in this course is complete SDLC, and all those 7 steps. Now you understand. You understand what is requirement, what are different types of requirement gathering techniques. You understand what is analysis, with include your data analysis, which include your front-end analysis, writing down a data mapping document, and then doing analysis on your data and all those things. And then for the front-end, thinking of designing how a front-end would look like, either screen mockups or use cases, all that is part of your analysis. Number 3 is your documentation, which you have template for BRDs and FRDs and user stories. And then you have coding, which you just understand what is coding. Basically, you have nothing to do with coding. Then we talked about testing. We talked about different types of testing, CIT testing, SIT, and most important, these 3 are for you, UAT testing. We talked about databases within these environments. We talked about implementation and maintenance basically are the last part. Implementation is basically when you finally launch your application, on which servers these applications are launched, how user access is given, and all those things. Again, your role is to provide documentation which you have already written, like FRDs, BRDs, any technical documentation for the implementation team, so that their job is easy. They know what this application is all about, how many users are going to use it, what times it is going to be updated, maintained, all those criterias, every SLA which they are going to design once the application in production, that is done by implementation and maintenance team. Within SDLC, to design any software, you have to go through these 7 steps. And these 7 steps can be implemented in different ways, different approaches. One was your linear approach, linear method, and one was your iterative method. These steps are necessary, these steps are not optional, they are mandatory, they're going to be part of any approach. But when you talk about linear approach, these steps will be used once in your product life cycle: one-time requirement gathering, one-time analysis, complete documentation, complete coding, complete testing, and then launching. When you talk about iterative methods, these steps are going to be used multiple times in iteration, in repetition. And one of the approach we talked about was agile scrum. And agile scrum basically is an approach where you break down your product into multiple components, and you call these functionalities as you add them in sprints. We call them sprints. Sprints are going to be 2 to 4 week long. A sprint basically is a complete development effort, but that is not on the complete product. That is going to be on certain functionalities, and those functionalities will be written in form of user stories, and you will put them on Jira, and then there's a product backlog and sprint backlog, and you move them, you track them. You have daily meetings, and then you have product development meetings, you have sprint planning meeting, you have retrospective meeting, multiple meetings you attend, and you finish all these sprints one by one. Okay, within the sprints you do coding, testing, implementation, everything. Not implementation, but showing to the business users. We talked about data warehousing, where we covered what is a data warehouse, what are different types of schemas in data warehouse, what is a table, what are different types of keys in tables, what is a data mapping document, what is an ETL process, how do you utilize SQL. So all these things we just covered in last 2 lectures. So this is overall your IT part of your BA. You have 2 parts. To become a BA, to become a good BA, you have to have 2 skills. One is your information technology, understanding of the processes which are needed to develop a software, implement a software, or enhance a software. And second thing is understanding of the industry in which you're going to work, which is your domain, which is one of the most important things. So the second part will start. Do you guys want to take a break for tomorrow and give me a test, or you want me to start with the domain session tomorrow? What you want to do? I want to take a complete test. I'll ask multiple questions. It's okay. It is going to be a kind of a practice session for you guys. Either you want to do it tomorrow, we can do it tomorrow. If you want to take one day and then go through the whole syllabus, we can do it next day. It is up to you. But I want to take a complete test where I can also, once you're done answering, then I'll answer as if I'm sitting in interview. So tomorrow is good.
It will be
Yes.
nice to test, yeah, tomorrow.
Tomorrow is fine. So let's do a test tomorrow. Go through all these topics. I'll be asking question, and then whatever answers you're going to give me is basically kind of definition. But once I'm done asking you question, I will also answer as I'm sitting in interview. So there are two angles to it. One is your angle and one is my angle. So we'll do that tomorrow. And once we are done with this, last half an hour I will spend on domain types, topics, and all those, so we can start our domain from Wednesday. So if you have any question, let me know. I've sent you information, documentation on ETL, data mapping, all those data warehouse, RDBMS. There's a document called RDBMS, Relationship Database Management System, that have multiple chapters. Just go through first 3 chapters. Just skim it through, just look through some definitions, primary keys and all those keys. What is an ER diagram? There are certain examples. And if you can please also draw one of the ER diagram. Don't need to draw it through a tool. If you don't have it, you can draw it on white paper, piece of paper, and attach that to an email. Take an image and attach that to an email. You can design any database, like a library database. So what tables a library might have. Okay, a hospital database, how many tables a hospital is going to have, or any bank database. You can just make up something, and then if you can design that, so ER diagram, that would be also good practice.
Imran.
Yes.
Okay. I did download the VCO, and I tried to master it, but I can't really find a good YouTube video that I could watch and master the VCO. So do you
It's
have
just
any
the
recommendation?
navigation. It is just the navigation you need to go into and find out where your use case diagrams, notations are. So business process flow diagrams or BPMN diagrams are going to be one category. Once you keep clicking on them 2-3 times, you will search and you will find out all those diagrams I was talking about. It's just the navigation part. Once you go into that part and you navigate rightly through the use case diagram, you will see all those symbols and notation. And then last part is just to drag and drop. You can take your mouse on those symbols, click on them, drag them, and drop in your page, which is your front page, and you can connect these signs together. It is easy to navigate, so please try 1 or 2 times. You will understand. If you're not, then I will see if I can show you tomorrow. But it is easy. It's just a navigation part that where you have to find what types of diagrams you want to work on.
Imran, the
Okay.
ER diagrams are for tomorrow. You want that to send you by tomorrow?
No, not tomorrow. You can do it later on. It's okay. Whenever you can do it.
Okay.
So all right, guys. Tomorrow a test, quick test. Please, everyone, do come. I need your involvement. You know even a word about what I'm asking? Go ahead, please. Okay. I'm not
Sir,
testing anyone. We are just trying to help each other here.
Sir, for tomorrow's test, we should go over just like everything associated with SDLC.
Yes.
Is
So all
that
these topics I
correct?
was just discussing: what is Agile, Scrum, what is Waterfall, what are different types of requirements, how do you gather requirement, what is the sprint life cycle, how many types of testing you've done, can you tell me what is a template for test case, or what is a use case, how you draw it, all these questions, whatever I was talking about. So go through, skim everything which I've given you. I think better approach would be to go on Google and search few keywords which you are not familiar with, certain topics which you're comfortable with. So go through those. I always Google things. I don't go through slides or notes. All these things pretty much have been given to me 6 years back, so I just forward them to those people who still believe in reading these, because I don't. I believe in reading Google. If I want to read anything, I will just simply go and say SDLC. Any topic, anything I find out, I will read. I will write down sprint. What is a sprint? Any query you have, any question you have, any topic you have, Google it. You will find so many different concepts, so many different things, so many different examples.
Understood.
Okay. And don't call me sir. You can call me Imran. We are friends now. And being a friend, my role is to make sure that you on board, you guys get a job. So I'm very flexible. Now you will be making mistakes and all those things, and I understand. When you go in resume, you will maybe panic first day that what is it, but eventually you will understand day by day. So any question you have in your mind, please do not hesitate. Ask me. Okay.
Will do.
All right, guys.
Okay.
See you guys tomorrow. Let's finish this tomorrow and start our training session on domain. Take care.
Take care.
Bye bye.
Thank you.
Bye.
Thank you.
Thank you.